Hello everyone, how are we doing? So we're going to go through the solutions to today's paper, the 2026 Maths Paper 1 higher level. In general, I have a reaction video for this already on the YouTube channel, but I'll give you the summary of that. It's a pretty tough paper. You could call it average, but leaning on tough. Okay, the issue is it kind of took a lot of time to do. Even doing it myself there, like I can normally hammer these full papers out, all their questions in like a little over an hour. But like this one took like 2 hours, to do all the questions. So I think it was just some of the longer questions were just tough. You had to like read them slow to make sure you're doing them right. And like I have to read them slow and make sure I do them right, that I don't give you like silly solutions, that kind of thing. But overall, yeah, I've gone through everything. I have all the answers and they're all right. And the idea is we're going to go through it now, and we'll see how you got on, of course. Okay, so they were nice here. They start off the question the exam fairly straightforward, as they should. People are a bit nervous, and you want to give them an easy question to get them going. All you do here is you bring the 1 over. 4 equals root a plus 7. Square both sides. 16 equals a plus 7. And then bring the 7 over. You get what you get. Is it a 9? Yeah, 9. Now you should always check these when you put them back in, and you can move on happy. So you get 5 equals 1 plus, you put a 9 in there. What's that? Root 16, isn't it? Root 16, and then that's a 4. So then that's definitely correct. So that's how you do that. Okay, rearrange this. This is like a kind of junior cert problem, but it's the kind of thing you want to give people at the start of a Leaving Cert exam to settle them. So get everyone away from the P first of all. 2 over P is 3 over S minus 1 over N. So we're going to flip both sides. It's probably the cleanest way to do it. So we want to write this side as a single fraction first. So we'll keep this side as it is. So we're going to multiply this guy above and below by N, this guy above and below by S. And so that gives something like a 3N minus an S over an Sn. And then we flip both sides. So I'll move up here to do it. So we get P over 2. You can flip both sides when you have a fraction on either side like this. You get Sn over 3n minus s, and then obviously multiply both sides by 2. And so then a 2 goes up there. And 2sn, 3n minus s. Yeah, that's correct. Okay, so keep moving. Now this was easy, so I done a video on the YouTube channel where I kind of was going through how you do, there's no need to use long division here, you can just use the factor theorem. And what if you're interested in just how ridiculously quick I get the other factor here, maybe you should go watch that video, okay? All you do is you just write the quadratic here, and you just write the missing linear. You write it equal to the cubic. There's no need for long division here. Go watch that video if you see something here you're very interested in, which you should be. You can just guess the linear. The linear is 4x, and then this has to be a minus 5, because this term by this term has to give the first term here, and the last term by the last term has to give the last term there. So that is 4x minus 5. Okay, so the solutions from this, when you set it equal to 0, because that's what this is, that gives a solution of 5 over 4. You can put in a 5 over 4, that make it at 0. You need this thing to be equal to 0. Now you can see you can divide everything by 2 once you set it equal to 0, so I'll skip a step here. I better not, I don't want, just because people want to kind of see things done out the way they would do them themselves in the exam. So you divide everything by 2 now, and 2x minus 3. This factorizes to a plus 3 and a minus 1. And so the answers there are a minus 3 and a 1. And you want to put kind of square boxes around them, make it clear. Now, they're pretty good in the state exams nowadays. So what they do is they get people to fill in things down here to make sure they know what to get. Okay, so that's good. That's a good habit they're in now. This is a bit of a curveball question. Okay, this doesn't really come up that much, if it's come up at all, maybe once. I don't know if it's come up in state exams. It comes up in mocks anyways. So the way you do this is you separate the 4. 4.366 recurrent is a 4 plus this thing. Okay, this thing just keeps going. Now, what this thing is in this box, we can do an S infinity on that box thing, right? So we can say that that there is really a 36 plus 0.0036 plus 0.00036. Now, what this thing is really here, this is 36 over 100. This is 36 over 10,000. So this is something you'd have done, in your book. You practice these in the patterns and sequences chapter. I hope I have the right number of zeros in there. The point is that this here is your first term, A, and the OR you get from taking the term after dividing it by the term before, and OR here is 1 over 100. And or, as you can see, is a modulus of it is less than 1, so you can use your S infinity formula in your tables book, 1 minus or, and you can use this because the modulus of or is less than 1, okay? So you just sub in here. S infinity is the first term, which is 36 over 100, over 1 minus r, which is 1 over 100. You can actually do this in your head. So you multiply above and below by 100 in your head. On the bottom, you'll get 100 minus 1, so that's 99. The 100 cancels on top, so that's really 36 over 99, okay? And then you just add that. So that there, this box here is 36 over 99, and then you just add that to 4. Where's my calculator? So you go 4 plus 36 over 99, and you get this thing. This would have been the answer to the question, 48 over 11. Now, the great thing about this is you can, just once you've got your answer there, just type 48 over 11 in your calculator and press SD, and it works out as 4.36363636, and it rounds the last number to 4. That's just because the calculator can only show so many decimals, you know. But that's your answer there. Okay, we'll keep moving along. Keep good pace here because we want to get this video out for within an hour for people if we can. This was a really easy. So people would have been really worried about financial maths, and they gave one of the softest questions you could probably give on financial maths, which was this here. So basically, you just turn an annual rate into a monthly rate. We even tell you the rate we want you to get. So you just go 1.084. You raise it to the power of a 12th. Then you go and you take 1 away from it, and then you times it by 100. So that's just how you'd show the work, and you can show it piece by piece. But when you do that, you'd want to write it like this. Let me do it here. 1.084 to the power of 1 over 12. 4 to the power of 1 over 12. And take away 1, times it by 100. So just write it out as a few more decimal places here. So I'd go 6.744%. It's in percentage because we multiply by 100, and then just round it the way they want it there. Remember, we call monthly rates or, so 0.674%. Okay, cool. This next part was so simple. You could have just used the amortization formula here, okay? And that's why, you know, it was probably maybe a little bit too simple if you're letting people just use an amortization formula and move on. But as I said, the exam overall was pretty tough, so you kind of got to give a bit of push and pull, you know, and so they gave a bit of a soft one here. So I'll write the series for people who are interested in learning something rather than just using a silly amortization formula. We'll use the formula afterwards though as well. So the idea is that 14k RIA gets us a loan is a big old present value, okay? Now, RIA or RIA makes these payments of A. Now, that first payment A, if you pause the video and read this, you've probably already read this, so you know. So this first payment of A is 1 month in the future. To bring a future value back to the present moment where this thing is, you need to divide it by 1 plus I to the power of 1. This is how you write the series. She then comes into the bank to pay off the loan. She comes in with this next payment of A. This is 2 months in the future. You bring it back like this to the power of 2. So the reason I'm writing this out is because they could have asked, show the series, you know, and hence or otherwise get the answer. So you're still expected to be able to show the series. So this went on for 5 years. 5 by 12 is 60 months, I believe. 0.0067. And then you just use your S infinity formula on this, where this here is your first term A, and or is equal to 1 over 1.0067. So I'm not going to spend too much time. And then Sn itself is equal to the 14,000. Okay, so I've done loads of financial maths questions like this on the YouTube channel. So if you want to see one of these done out a bit slower, go have a look at one of them. So Sn equals A times 1 minus r to the n over 1 minus r. So we sub everything in here. Let me get a good color. So in for Sn, we put 14,000 equals A, which is this awkward looking thing, 1.0067 times 1 minus r is this, and then it's the power of n, so that really looks like this when you sub it in. 67 to the 60, and then that's over 1 minus 1 over 1.0067. Now, the way you could do this is you could replace the A there, factor it out, put a 1 in there, type all of that into your calculator as an answer, and then go 14,000 divided by answer in your calculator. But you'd want to just show that being done for the examiner, whatever blue number you get here, write it in, you know, in another separate line. Anyways, the A here, the A for this works out as 284 euro and 14 cents is what you should have got there, okay? Now you could have used the amortization formula. Financial maths, and then there's this formula here. Now, the reason I don't like people using this formula is because if they made you write out that series and you don't know how to write the series, it's a complete blunder, you know. So 14,000 is the big P, then it's multiplied by the I in the question, which is 0067 times 1.0067 to the power of 60 over 1.0067 to the power of 60, and then take away 1. You type all that into your calculator and you'll get the same thing again, 284.14. Make sure you include your euro symbol, okay? Right, but that wasn't the end of the question. But what was nice here is they said there was something else you had to get. You had to get the interest, but they're doing nice things now in the exam where they remind the student, don't forget there's another thing you got to get, okay? So the idea is here, this Raya or whatever her name is, pays 284.14 to the bank 60 times, okay? 60 times they walk in with that payment. So if you go 60 by that number, I better check it again here in my calculator. You go 60 by 284.14, you'll get this number of 17,048 euros and 40 cents. But how much did you actually borrow from the bank? You only borrowed, I think, 14,000. Take them away and you get the interest that the bank made off you. They made 3,040, and you can steal the euro symbol there for the unit, okay? Great. Right, we'll keep moving along. That was an easy financial math question, but as I said, overall the paper has some pretty hard stuff. So they kind of had to give us something easy. We use the product rule here for something like this. So you go u equals 7x squared. You go phi equals cos 3x. Underneath u, you write du dx, which is a 14x. Underneath the v, you write dv dx. Okay. And the derivative of cos becomes minus sine. You keep the inside exactly the same, and then you multiply by the derivative of the inside. Okay. So you could tidy that up in another line. I'll tidy it up here in one line. You put the 3 in front. Okay, so then you sub into your product rule formula. So this gets you dy dx, or you can call it f dash x, whatever you're into. So then this in your tables book is u times dv dx, so then it's 7x squared times dv dx, which is a minus 3 sine 3x, and then it's a plus symbol, another 2 brackets. It's v times du dx. Now you won't actually tidy that up. Now, to be honest, you could waste time tidying it up, but to be honest, what is it, like minus 21x squared sine 3x and then plus 14x cos 3x. You can use a line there to tidy up. But they shouldn't be deducting marks for tidying it up because they wanted after this you to sub in the value for pi. So, you know, why would you tidy it up if you were subbing in a value, that kind of way. Now, the main thing is people need to realize here, if you type, make sure your calculator is in radian modes, of course. Shift mode, radians, yeah. You type sine 3 pi into your calculator, you'll see it's a 0. Okay, because 3 pi, let me use the unit circle thing here because we want to kind of teach people things as well, of course, rather than just watching solutions. Where is the location 3 pi? So you've obviously gone around the circle a full pi to go back to here. So this will be the location 2 pi. You go all around and you come back to 2 pi, and then you go around pi again, so you land here. So this is where 3 pi is located. You've gone around 1.5 rotations. Sine 3 pi is the y-coordinate of that point there, and the y-coordinate of that point is 0. So that's why this thing has a value of 0. So then cos 3 pi is the x-coordinate of this point here, and that's a minus 1. So if you type cos 3 pi into your calculator, it gives minus 1, okay? So hopefully people make sense of that. So when you put pi in here, this thing goes to 0, and then what this produces is a minus 1, and then this is a 14 pi, okay, when you put in the x. So the answer here is minus 14 pi. Okay, so nice to be able to do things like that without a calculator, you know? You need to understand your unit circle. There's a great video on the, because you have your paper 2 coming up, on the unit circle that I recommend everyone watch on the YouTube channel. You'll learn loads about what I just done there and how I knew sine 3 pi was whatever it was there, 0. Okay, so this was a bit of a fair game question as well too. This isn't too hard. But it's a bit of a coded instruction, so there's a lot to make sense of here. The function g of x, we're given the second derivative, we are. Okay, let me zoom in on that because it's a little bit pixelated. They tell us that the slope of the tangent, right, is minus 2. So they basically told us that g dash x is equal to minus 2 when x itself is minus 1 in there, okay? So first of all, we'll integrate this, right? We'll integrate it. We'll get our g of x function, g dash x function, by integrating this thing, And don't forget your dx, okay? Don't be the students not writing dx. The integral of this becomes 15x squared minus 18x plus c. Now we were told that g dash x is equal to minus 2. I'll write it like this first of all. We were told this guy is minus 2 when x is minus 1, okay? And you can read that slowly if you don't believe me. Minus 1 squared minus 18 minus 1 plus c. This is minus 2 equals, that's a plus 15, that's a plus 18, and this is a c. That's a 33, you bring it over, and you see c is minus 35, okay? C is minus 35, indeed it is. Okay, so then we come down here now, and we want to get g of x. So what we've got to remind ourselves is what was g dash x. G dash x was 15x squared from a second ago, minus 18x was minus 18x, wasn't it? Yeah, it would be. Minus 18x, and then our newly found minus 35. So then to get g of x, we got to integrate that guy. So this, you got to show the workings. Don't forget the d of x, okay? Don't forget your d of x. This then becomes, you increase the power by 3, divide by 3 then, so it's 5x cubed minus a 9x squared minus a 35x, and then a plus c. Now, remember, this is a y value. This is a g of x, right? So we have a point on this curve. We know that when y is 8, x is minus 1. So that can actually get us this. So when you're 8, x is minus 1 cubed minus 9 minus 1 squared minus 35 minus 1 plus c. Right, bit of stuff going on here. So you got 8. When you cube a negative number, it stays negative. Minus 5, and then this is a minus times a plus 1, so that's a minus 9. Then that turns into a plus 35. The minus 5 and the 35 give a plus 30. This then gives a minus 9, so you're on plus 21. You bring the plus 21 over, hit the 8. 8 minus 21. So c is minus 13. And did I get that from earlier? Yeah, I did, yeah. So you just want to restate the full function now. So g of x, they gave you a box down here on the bottom. You see they're doing this nice thing now. So the answer is 5x cubed minus 9x squared minus 35x, and then our newly found minus 13. Great, and it's a cubic as you'd expect, you know, because the second derivative was a linear. Now we have a complex number question. The very first thing is really, really easy. This is a little bit tough, and then this is extremely tough, okay? If you don't know what to do. Okay, so we'll get into it. We obviously need to write down what the conjugate is because we have to sub it in. It's 3 plus 7i. So then the instruction is go 2 times the conjugate and then add it to 5i multiplied by the original, which is 3 minus 7i. This gives a 6 plus a 14i. 5i by this is a 15i. Now, 5i by minus 7i is minus 35i squared, and that changes to a plus 35 because i squared is minus 1. And so the answer there is 41 plus 29i. I think that's what I got earlier on. It is indeed. Okay, so the next thing here is a bit tough. It's De Moivre's theorem, and the complex number we have to write in polar form. And you have to use De Moivre's theorem. You couldn't be a silly student and go and like 8ing that out with 8 brackets because you get 0 because they say this here, you know. So if you done that, hope you didn't do it. Okay, so the idea is, right, you've got to plot when you want to turn a complex number, and I've loads of complex number tutorials on the YouTube channel for people. If you want to turn a complex number into polar form, you need to plot it first. So you come over here at 3, and you come down here. You should know root 3 is about 1.7-ish for a good diagram. So then that's your minus root 3 there. So it's a 4th quadrant job, okay? That's where the complex number is. Now we need to get this angle all the way around to there. Now the rule is we go 2 pi minus a reference angle. Now we get that, that's the first quadrant reference angle. We get that first quadrant reference angle by going tan inverse the positive b over a. So you see b is negative here. So you go a plus root 3 over a 3, okay? And you should be able to do that in your head if you can know your unit circle tricks. That's pi over 6. All this should always be not in degrees. You should be in radians by default, okay? As I said, there's loads of tutorials for complex numbers on the YouTube channel. Anyways, that's the pi over 6. So it's this we put here, it's pi over 6. So the actual angle we want, the theta, is 2 pi minus pi over 6. And that in your head is 11 pi over 6. Or you can just type 2 pi minus pi over 6 in your calculator. Now you need the modulus as well. We need, just so you understand what I'm looking for here, I'm looking for or, you'd want to say this for the examiner as well, or cos theta plus I sine theta. So I've got the theta now, which is the hard part. So the or is just the modulus of z, and that's the square root of a squared plus b squared. So you don't worry about the signs here. You just go basically like 9 plus 3, because root 3 squared is 3. So this is root 12, and root 12 is 2 root 3 in your calculator, okay? Because that's root 4 by root 3, which is root 12, 2 root 3. Okay, so then z is equal to 2 root 3 cosine 11 pi over 6 plus I sine 11 pi over 6. Right. When you change something into polar form, you should always go and just multiply it back out and make sure you get the original thing, 3 minus root 3i. So in your calculator, you can go 2 root 3 times cos 11 pi over 6. That'll give you a 3. Go 2 root 3 sine 11 pi over 6, and that'll give you a minus root 3. Now I'll just do that myself here just to be sure, because once this video is up, I don't want you in the comments saying that's not right. Okay, that's first thing is right. And that is right. Okay, so that there in pink is absolutely 100% that thing there, okay? Now we got to raise it to the power of 8, so then you go z to the 8 for the examiner. So you can do a bracket 2 root 3 to the power of 8, or you can just write the number. The examiner won't really be giving you any marks for realizing that that number is 20736. But then you want to actually definitely write the angle here, the fact that you're multiplying this by 8. So then that will be like 88 pi over 6. You would want to show them workings rather than just typing that into calculator, because this is fairly obvious that you raise this to the power of 8, you know. Save yourself a line for the space, you know. Over 6. So yeah, De Moivre's theorem, you just multiplied the angle, the theta, by the power. So then you type this into your calculator. You obviously can't do stuff like that in your head, it's crazy. Or you could, if you want. So the idea is there, when you type that in, I need a good color, z to the 8. When I type this purple thing in my calculator, I get 20736 cosine 88 pi over 6. So that then works out as a negative, it's a big silly number, 10368. Now the unfortunate thing for people, and I'm sure you've done this if you were doing this in the exam, when you change that to a sign, right, you get a decimal thing. You would have gotten this decimal of 17,957.903 rounded, okay? Ideally not to leave it like that, okay? But they'd still give you probably full marks for that, no issue. But the way you would work this out, without letting your calculator put it into a decimal, just type into the calculator what sine 88 pi over 6 is. You will see that this thing here that I'm circling is root 3 over 2. So then just go root 3 over 2 multiplied by this number, and you'll see that this awkward decimal thing you were trying to write down is actually, let me write it here maybe in the black space, it's 10368 root 3 I, okay? So that there is the non-decimal version of that. Okay. Again, that looks really messy on the screen. There's loads of, if you're coming at this and you're in 50 or whatever trying to learn complex numbers, there's loads of videos on the YouTube channel to teach you this. But yeah, for today's solution anyways, it's this thing plus 10368 root 3i, okay? Or you can write it down there with a decimal and don't forget your I. Okay, right, let me clear that away. Get away from that thing. We're on to this. Now this is a bit of a tough question, okay? So you can pause the video, obviously read it. This is the big thing here, okay? They tell us that the modulus of W is 5, so then we know A. This isn't even an unknown, okay? So we know that these things somehow got multiplied together and they give a real number, okay? So that's kind of interesting thing. Like that's usually, that tells us something, right? But the main thing is here, we know B. B has to be 3, right? B has to be 3 because all that, and I'll just confirm something as well. Let me remind people of something. All right, it's probably quicker than going to the book. If R is cos theta 1, or this is R1, plus sine theta 1, this is in your textbook with an I there somewhere, yeah? You can put the I in the front, it's probably neater. And if Z2 is R2 cos theta 2 plus sine theta 2, and then don't forget the I. The rule is when you multiply two complex numbers together, what happens is Z1 by Z2, the moduluses multiply, so you get R1, R2, and the angles add, so you get theta 1, theta 2, and this was in your textbook, okay? So I think I was quicker writing that than scrolling through the textbook. Okay, so that is how I know B is 3 because of that. Okay, so what you would do if you want to show the workings for that, you would just show that A by B, um, which is the modulus of W times the modulus of V, has to be equal to the positive 15. Okay, because the negative signs come from the cos thing here. Okay, so yeah, so anyways, we know B is 3. Now the idea is here, when you multiply them together, okay, so I'll set minus 15 is equal to, as we said, 15, and then it'll be cosine, so that's me multiplying the A and the B to get the 15. So then add the angles, so you get theta plus 160 plus I sine theta plus 160. A lot of people would have found this question a bit tough, you know, it is a bit tough. Okay, so how on earth is this thing going to give a minus 15? Well, this tells us something about this over here. This is the imaginary part with the I. This final answer has no I. So this thing has to have given a value of 0. So things for the examiner that would have gotten some marks here is realizing that this thing has to be 0. And then this thing here, if this is a minus 15, this thing has to produce a value of minus 1. So we know that the cos theta plus the 160 has to give a minus 1. Now, what you could do is you could try some cos inverses, sine inverses here, but this is really a unit circle problem from here, right? So we need to go to our unit circle. Let's talk about sine first. Sine is the y coordinate of this green dot. Where is the y coordinate? 0. The y coordinate is 0 here and here, and that's when the angle is 0 degrees and 180 degrees. Now, what is the angle? The angle is the thing inside here, right? So that is saying that theta plus 160 either equals 0 degrees or theta plus 160 equals 180 degrees. So it doesn't say theta can be positive or negative. So at the minute, we can get two thetas here. Theta can be minus 160 or theta can be 20 degrees, okay, from this. Now, we go to our cosine. There's only one location where, let me make a brand new unit circle, because as I said, rather than just showing you solutions, it's nice to actually teach you where things are coming from, you know. So where cosine is the x coordinate of this green dot, right? Where is the only place that that x coordinate of that green dot can be minus 1? And it's here. Okay, and that's when theta is 180 degrees. Again, you got to watch that unit circle video, okay? So then we know that theta plus 160 has to be 180 for cosine to ever give a minus 1. So theta here, if you were to sub it in, theta has to be 20 degrees. So that is the answer. We throw away this negative one. So the answers here, and I think they probably give space down there for this. The answer here is 20 degrees. And then one of the, I forget which one, but you know one of them was 5 and 3, okay? A is 5 and B is 3, okay? Why did they say one set of possible solutions? Because there's other solutions if you spin around the circle again. So 20 degrees was one solution. And then if you go around the circle again, like 380 degrees is another solution to this, okay? And it goes on. You can just keep spinning around the circle. Okay, cool. All right, we'll move on. So yeah, there were our answers there. Let me turn the page here. A was 5, B was 3, and theta was 20. Now we have a bit of a tough question here in 5. Again, this, you know, it's a time-consuming exam. So we should have no bother with this first part here. So we should know that that's 4 to the 3. Now this was a bit tough. So this is 1 over 4 squared. And when you have a whatever your power is on the bottom, when you bring it up the top, it changes sign. So this thing here is really 4 to the minus 2. And you can confirm that in your calculator. By typing 4 to the minus 2, you'll see you get a 16th. What was interesting about the 2 then, 2 is really the square root of 4. Okay, if you take the square root of 4, you get a 2. So then the square root of a number is it to the power of a half. So the answer there was 4 to the half, right? Okay, this was a really tough thing down here with the diagram. So let me see, can I snip the numbers that were meant to slot in here? And see, can I write them in? And I'll write them in using the writing tool on the whatever Microsoft called this PDF viewer. Okay. Oh, is there a way I can kind of get both of them? Anyways, we see the numbers, so I have to kind of put these numbers in here. So what I'll do is I'll kind of rewrite them first. Everyone can see that. So this is 4 to the 3. This is 4 to the minus 2. Now this is a root 3. Okay, so let's obviously pause the video, give this a go. Let me zoom up here for people who didn't see it. You can understand that A is, and it gives you the hint anyways at what they are. This is multiples of 4. This is anything that can be written as 4 to the power something. And then R minus Q, that's the irrational numbers, okay? So let's do this. I said pretty tough question this, okay? So I'm just going to kind of do the solutions. I don't like these Venn diagram things myself. Um, so the idea is this thing, it can be both written as a multiple of 4 and it can be written as something to the power of something. So this here, we would put here. Now you got to write 64 in there. Got to write the 64 in there, not 4 to the 3. This is 4 to the minus 2. That's not a multiple of m, where m, as you can see up here, is an integer. Okay, so that would just go here. Okay. Um, this is an irrational number, and it can't be written as any of them up there. So that's a root 3. This is a tricky one here. So this is an irrational number, or less q are irrational numbers, but this can also be written as 4 to the half. So this can be both irrational and written like that. So that's the root 2 there. The 12 then can't be written as 4 to the r. You can confirm this by going 12 equals 4 to the r, and then you use logs, or get the power on its own to the base for 12, and that works out as a decimal. And or isn't meant to be a decimal thing. So this can't be written like this, so that just goes here. And then we've the number 1. Now, where could you put the number 1? So it's definitely like 4 to the 0. Okay, so that's in there. And m, yeah, so I would be putting the 1 there. Okay, so because I can't write it, I can't multiply 4 by something that's an integer and get it there. Okay, so let me confirm that myself with my solution. Yeah, so putting the 1 there, good. And then there was this little kind of curveball question down here. Write down one element in real numbers that is not in any of these sets. So for people who've done this, you want to basically write down any number that's not a multiple of 4, okay? And that can't be written like this. So like the number 3 would have worked, okay? And the number 11 would have worked. So the reason 12 ended up in here is because it was a multiple of 4, that kind of thing. So 3 or 11, something like that's fine, okay? All right, let me clear this away. Okay, so I have the screen tidied up a little bit after that messy Venn diagram one. So we're back here now. Right, this was an easy question to get people settled after that Venn diagram thing. Basically, we're looking for something unknown in the power, so we need logs. So the whole point of logs is to get the power on its own. Then the base stays the base, so that's a 4. And then that leaves room for the 9 here. Now the idea is I've loads of videos on the YouTube channel teaching logs, so if this any fifth years doing this, you can go have a look at them. Okay, so we've got to change the base here. There's a hint to change the base. So the way we change the base, it's easy to do. So this is log 3, log 3. Who's ever the taller one goes on top, and that's the smaller one on the bottom. Now log 39, you can type that in your calculator, it's a 2. But the reason it's a 2 is because it's 3 squared, and the 2 pops out the front, and log 3 is a 1, so it's 2 times 1. So then this is really a 2 over log 3 4. Now I'd be leaving my answer like that. A lot of people hopefully left their answer like that. But you could actually simplify this, and they didn't explicitly say here, I think, simplify it. Log 3 4 can be written like this. You can go log 3, 4 can be written as 2 squared, and that 2 can pop out the front. So this here could have been written, I'll do it over here. This thing here could have been written as 2 log 3 2, and then you could have cancelled the 2's there, and so you could have left k as 1 over log 3 2. But again, they didn't explicitly say to simplify it as much as possible, so it's completely fine to leave it as 2 over log 3 4. Okay. Hopefully people are good with that. Hopefully people are good with that. Yeah, that's all good. Okay. All right, let me clear that away. We'll just move along. Now, this was extremely tough, okay? So these don't usually come up, and so people would have been really horrified by this, okay? Because I think you have to do question 6, unless they say you can do, I don't know what it is nowadays. It's like maybe only do 5 out of the 6. I think that's what it is. Okay, once upon a time you had to do all 6. Okay, so the idea is here, this is a proof by induction question, and it's the inequality version, okay? And these are really tough, and they rarely come up. And I have loads of tutorial videos on how these are done on the YouTube channel, but a lot of people just don't like proof by induction, so they don't really do it. Anyways, I'm just going to do a solution out. You can go watch those videos if you're interested in it. You're a fifth year or whatever. Okay, so n begins from 7. So step one is always prove for whatever the first possible thing is. So prove it works for n equals 7. Okay, so we're going to prove this. So then we type 7 factorial is greater than 3 to the 7. You type that into your calculator, you'll see that it's 5040 greater than 2187, and you just write that that's true. Okay, so that's step one out of the way. So I'm going to clear that away. Right, so that would still be on the page, obviously, for you. Step two then is an assume step. We assume true for n equals k. So the idea is that k factorial is greater than 3 to the k, and you pick up your marks there. Okay, then step three is we're to prove the thing is true for n equals k plus 1, right? So then you sub that in and you get yourself a k plus 1 factorial is greater than 3 to the k plus 1. Now you got to know something here, right? You got to know that this thing can be written like k plus 1 multiplied by k factorial. You can basically, now I done tutorial videos on that, and that's actually needed in the next question. So you're going to see a bit more of that in the next question. So if you didn't know that, this question would have been really tough. This as well too can be written as 3 to the 3k. The reason a rule of indices is the powers add, so you can just do it backwards there. So that'll be the first step there, okay? So that's needed to get things going. So now we need to somehow prove that purple statement true. So I'm going to put a pink star beside this. If we can prove this pink star true, we win. The question is solved. Okay, so the way these work is we define something called the in-between. And what we do is we remind the examiner of what we assumed. Okay, we assumed something. We assume that k factorial, this thing up here, is greater than 3 to the k. We then make this thing look like this thing on the left. So I multiply both sides by k plus 1. And again, if this is confusing, there's loads of tutorial videos for this on the YouTube channel. Okay, so I'm just multiplying both sides by k plus 1. Right? Times 3 to the k. Now, we want to prove, reminding ourselves, we want to prove that pink star, right? So to prove that pink star true, we do something called dividing the in-between, right? So I'm going to split this up for a minute. So I got my k plus 1 times my k factorial. This is the purple statement we're trying to prove true. We're going to do a greater than, and we're going to do another greater than, and we're going to put this guy at the end, okay? So this is the in-between thing, and the hint then is the in-between thing will be the thing we have down here, okay? This k plus 1 times 3 to the k. So let's remind ourselves what we have here. This part of the statement, let me get the right color, I'll use green. This part of the statement is true. We know that's true because this is from our assumed true where we just multiply both sides by k plus 1. Another really important thing is, why am I allowed to multiply both sides by k plus 1? This is an inequality. If I multiply both sides by a negative answer, this isn't allowed because then the sign could change, But I'm allowed to do this as k is greater than or equal to 7. So I have guaranteed multiplied both sides by a positive number. So maybe good to put a disclaimer like that in for the examiner. Anyways, this thing is true here. So we can prove the full purple thing true if we can just prove that this thing is true, okay? So we can put a true question mark there, okay? That thing is definitely true. We need to prove this thing true. And then the order is correct. Then the first thing is obviously bigger than the thing at the end. It's way bigger. Okay, so let's prove this thing true. So then it's k plus 1, 3 to the k, greater than 3 times 3 to k. Now look at it carefully. This thing is obviously true. K plus 1 is obviously greater than 3 as k is greater than or equal to 7. So it's therefore true. Okay, so then therefore this whole, you'd have more room than me in the exam for this, but then this whole thing is true. Because if this is bigger than this and this is bigger than this, then this is obviously bigger than this. So then therefore the thing we wanted to prove in pink is proven. This thing at the very beginning, k plus 1 times k factorial, is bigger than the thing at the end, 3 times 3 to k. Okay, and that's true. Therefore true. 3 dots means therefore. Okay, so that'll be basically full marks. All you got to do is you got to add the step 4 then. So as it was true for n equals 7, and we proved true for n equals k plus 1. Therefore, 3 dots, true for n equals 7 plus 1, n equals 8. And it's true for n equals 8 plus 1, n equals 9. Dot, 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 true for all n greater than or equal to 7, where n is an element of n. Okay, full marks, they'll leave you alone. That for So there's loads of tutorials for that on the YouTube channel where we're kind of coming up with that in-between thing, you know, and doing the triple inequality. A very tough question, okay, very tough question. A lot of people would struggle with that, okay. It takes loads of time as well to do that out. So question 6 was tough this year. Okay, so this here, I done a tutorial video on this. This was like 2 probability tricks. So this is a nice short video on the YouTube channel. For anyone who had seen it, they would have been well prepared for this. This was due to repeat. I think this came up in 2018 where I done the example from. So anyone who watched that video was well prepared. Anyways, we'll keep going on here for the sake of time. So the idea is here, you can write something like 7 factorial, right? You can start, we all know it's 7 by 6, by 5, by 4, by 3, by 2, by 1. But you can stop whenever you want. You could say, I just want to go 7 by 6 and stop. Well, then you can say this is 7 by 6 by 5 factorial. You can stop when you want, okay? So that's what we do here. We're going to start multiplying down from n minus n plus 1. So we go n plus 1, multiply by n, and then we go n minus 1, but we stop. And the reason we stop is because there was an n minus 1 on the bottom factorial, and then we can just cancel them out, okay? So do you see why we've done that? So then this problem just becomes n plus 1 multiplied by n equals 156. So then this is n squared plus n equals 156. And so you get n squared plus n minus 156 equals 0. And that factorizes to a plus 13 and a minus 12 from what I remember. If I can scroll over the page, confirm. Yeah, that's correct. And so n can be minus 13 or n can be 12. N can't be negative here, okay, because it's a natural number, and so the answer is 12. And you can check this in your exam to make sure you're happy. You just put it back in, check with your calculator, is 13 factorial, put 12 in the bottom, over 11 factorial, 156, and indeed it is when you type it into your calculator. So you know you definitely done it right. Okay, this was a really tough question, okay? So a lot of people would have struggled with this. So it's a geometric sequence, right? So we got to know something here. Right, when you're dealing with the geometric sequence, T1 is A, and then T2 is AR, because you've just multiplied by the common ratio, which is R. And then T3 is AR squared, because you multiply again by R. Right. They say that with this first instruction is A is less than 2. Then it tells us the sum of the first 2 terms is 2, right? We can just write that in. A plus AR is 2. So this, if you didn't know this, this question was very hard to get off the ground. Now you could have actually used trial and error and you've got 3 answers and they would have probably left you alone. You get full marks for that because they don't say you have to do it a specific way. They just say come up with one possible thing that's true. So you factor out the A, you get 1 plus R is 2, and you get this important equation that A for this question is always equal to 2 over whatever 1 plus R is. So that whenever the marking scheme for this comes out, that'll be something that'll be worth marks, okay? That the student was able to come up with that based on what statement 2 was telling them. What does statement 3 tell us? The sum of the first 3 is less than 2, so let's write that in. So then that means A plus AR plus AR squared is less than 2. What I would do here is I'd factor out the A plus R squared is less than 2. I'd sub in my newly found A thing, so then I get 2 over 1 plus R times 1 plus R squared. 2. Now this was a tough question. I'm going through this pretty quick because I know how to do this, but this took thinking about when I was doing it for the first time. So you can obviously cancel the 2's on both sides, and you're left with something like this. 1 plus R, I'll write it the other way now because they're better like this. R squared plus R plus 1 over 1 plus R is less than 1 because we divide it by the 2's, you know. Now this is an inequality. So to be able to multiply across by 1 plus R, you need to multiply by 1 plus R squared on both sides, okay? So you go 1 plus R squared times 1 plus R squared here. And so that obviously cancels with that. And so what you'd write here for the examiner is 1 plus r, all right, times r squared plus r plus 1 is less than, you'll square this thing out then as well, so that becomes r squared plus 2r plus 1. And then you want to go and times all this out then as well. So let me see, can I make room? So hopefully you're following along with my voice and whatnot. Tough question, tough question. So you're going to get 6 things when you multiply this out. I'll just kind of times it out here. So when you times the 1 in there, you get an r squared plus an r plus the 1. Then timesing everything by r, you get an r cubed plus r squared plus r. And then that's less than r squared plus 2r plus 1. Very tough question, as I said. Stuff cancels here. The r squareds cancel. The 1's cancel. And then 2r and an r. So one of your r's will cancel. Oh, well, we actually have 2 r's here. Let me see. Let me look at this properly. So you see you have another r there. And so that will cancel with the 2r there. So if I have seen this correct, all that gets left here is just, it looks a bit messy, my workings there, but all that's left is r cubed plus r squared, and then that's less than 0. Let me confirm from my workings earlier if that's correct. That is correct. Okay, so I've reproduced what I got earlier on. So what you got to do now is factor out an r squared from that. Very tough question. So r plus 1 is less than 0. Now, this is pretty tough. So because r squared is positive, right? It's guaranteed to be positive because it's a number squared. You could just divide both sides by it. And so you're really just dealing with the scenario, is r plus 1 less than 0? And what does this mean? This is true if r is less than minus 1. So that is, in terms of the marking scheme, that is something you've got to kind of come up with. You know, it's a pretty important realization that r has to be less than minus 1. So r is negative and its number, r could be something, for example, like minus 2, or r could be minus 3, okay? That kind of thing. And then you can just double check this. So I'll put, like, let's say r is minus 3, because we can pick any possible scenario we want based on, as long as it fills the conditions. So say we choose minus 3. You put it back in here, see if it works. That gives a plus 9. Then this will give a minus 2. And so that gives a minus 18, which is less than 0. So it satisfies the condition. So r equals minus 3 is fine. So let's do that one. So if r is minus 3, you sub it in here. You go 1 minus 3 on the bottom. That's a minus 2. So that will give a is minus 1. And so then what the pattern is, if a is minus 1 and r is minus 3, well then the very first term, I'll write it in here. So the very first term, t1, will be equal to whatever a was there, so a is minus 1. t2 will be a times r. If a is minus 1 and r is minus 3, then that will give a plus 3. And then t3 then is got by taking our previous term and multiplying it by minus 3 again. So that's a minus 9, okay? So there we had t1 was minus 1, t2 is 3, and t3 is minus 9. Or you could have just done it as well too with the minus 2 and got another 3 different numbers. I think they wanted s3 then, so for me here, minus 1 plus 3 is 2, and then add minus 9, and so I get a minus 7 as my answer there. Again, that's crazy messy on the screen there for you to have to read, but that's what the solution was for this question, as tough and nasty as it was, you know. Yeah. Okay, I'm happy I've shown you that correctly. Yeah, okay. So yeah, that was really tough there. So hopefully people made sense of that. So the video's on 48 minutes. Christ, how am I going to get through all of this in an hour? Okay, so we'll get moving along here as quick as we can. So you're told some function here for the volume of water in the water tank. You got to be very careful. T here is in seconds, and they give you a time here in minutes. So then that means T is 60 seconds. Okay, so you just put it in here. So V is 60. Is equal, this isn't the tough part of the question, times 60 cubed minus 9 times 60 squared plus 550.8. You'd have to show these workings for the examiner, you know, plus 68900. You type that into your calculator. You should get 749. I think that's a 48 cm cubed. Am I right? Okay. Yeah, I just don't have the time to type that in again, but it's whatever that comes out to be. I think that's the number, 74948 cm cubed as well. You take the units in the question. Anyways, I'm sure everyone can sub a number into a function. That's not what you're here for. So use differentiation to get, they tell you you want dv/dt when we're 150 seconds into the problem. So let's get dv/dt here. Easy question this to start off. So then we take a derivative of this, multiply down by the 3, so that becomes 0.75 t squared. This becomes an 18t, and this is 550.8. Right, so we then want to get the value of this when t is 150. So you would have to show this subbing in for the examiner. You would need to go 150 before you pick up your calculator, because you can type things into a calculator wrong, so you want to show that you knew how to sub in properly on the page first. 0.8, okay? And you type that into your calculator, and you should get this number of call it what it is, dv dt is equal to this number minus 461.7, and then that has units. They tell us the units in the question, but we could have worked the units out from the derivative. V is in centimeters cubed, t is in time, which is in seconds, so cm cubed per second. Okay, great. Right, I'll keep moving. So find the range of values for this guy's decreasing. Okay, so what you've got to know is, I'll need a certain thing from here. I'm going to need my dv/dt, so let me not make this too messy for you. You can obviously be trying this yourselves. Okay, so there's something you should have learned in a flashcard, is that when a function like v is decreasing, its derivative is less than 0. So they have basically given us an instruction here to set the derivative less than 0 like this. Okay, so that is you'd use another line, of course, to be neat about that, but basically that's what we're doing. We're solving a quadratic inequality here, and I showed in the algebra tutorials on the YouTube channel how to deal with quadratic inequalities. So you go and you use your minus b formula on that. You'll get two solutions. They're not your answers. The two solutions are 36 and 204. You know what I mean? But you'd want to show it for the examiner using the quadratic formula. So you'd want to go t is equal to minus b minus 18 plus and minus the square root of 18 squared minus 4 times 0.075. That's the a times the c all over 2 times a. That's a 2. 0.075. Okay, you type that in with the plus and minus, you'll get 36 and 204. So they're not your answers. When you're doing these quadratic inequalities, you've got to draw a number line. On the number line, you got to put 2 dots. You put the very first solution here on the far left, and then this on the far right, because it occurs first on the number line. 36 is before 204 on the number line. What shape quadratic is that? That's a U-shaped quadratic. You sketch a U through this. And then the final thing is, what is this function to 0? It's less than 0. So you shade in the part of the curve that's below the number line, and so you describe that region. That region is t is less than 204 and greater than 36. Okay, and great if you can write seconds in on that, that'd be great, because t has units. So it's between 34 and 204 seconds. Okay, that's when it's decreasing. Less than 0. So that was a quadratic inequality question. They come up, so people might have been prepared for that question. And sure, you'd know you kind of done it right because you got nice numbers of 36 and 204, Right, so then we do move on to this here. So they tell us that the actual shape of that tank is a cylinder and it has a fixed radius. So we can write the volume of a cylinder formula from your tables book, and then we know R is fixed. So then you type in 26 squared h into your calculator, and you should get 676 pi h. So that's V. Now, what we're asked for in this question is to get dv/dh first, so we'll get that out of the way. dv/dh, because it's just got a h in it, it works out as a constant like this. Okay, after we get that, we're then, if you read the question, you pause the video, read it slowly, find the rate of change of height with respect to time. What they want us to get here is dv/dt. Now, I've done loads of rates of change question on the YouTube channel. So what we do is we pull this thing apart, so you can go watch tutorials on this if you're in 5th year and you're interested. you pull it apart like that, and it makes sense then to put it, you can put whatever you want in here. You put the number 7 in there if you want. It'd cancel down. You go back to dv/dt. It makes sense to put dh in here, right? So now we just need to get these two things, multiply them together, and we get our answer, dv/dt. So if you think about it, we already have dv/dh, okay? It's this number here. No, I haven't pulled that apart, jeez. So let me fix that up. It was h we wanted. We wanted dh dt, okay? So that means a h has to go here. Sorry about this. Okay. So yeah, you want dh dt, the rate of change of height with respect to time. Okay, so you pull it apart like this, and then you can put whatever you want in here. So it makes sense to put dv in here, okay? So as we have dv/dh, so dh/dv is just 1 over this, okay? Because if dv/dh is this, dh/dv is 1 over that. Hopefully that makes sense to people. It's a pretty common thing to be doing in rates change question, flipping something. dv/dt when the time is 150 seconds. So we already got that there a second ago in the previous question. That was the minus 461.7, okay? So you just multiply those two numbers together, and when you do that, you'll get an answer of minus 0.22. Now, they give you the units for this, but you should have known to kind of get the units yourself. H is in centimeters, T is in times, so this is in centimeters per second, okay? So that works out as that, yeah, when you multiply those two things together. Okay, hopefully people are good with that. That was a rate of change question. We come down here, and we have a brand new container, and C. Now you got to read what C actually is. C isn't the volume. C is something that models the rate at which the height of water in this new tank or container is changing. So if you read it carefully, it says, oh yeah, so something else I said, I'd show that previous function in Desmos so we can see what we're dealing with. So let me type him into Desmos there, because it's nice to see this. 0.25 x to the power 3. I think it was minus x to the power 2, minus 9x squared to the power 2. Yeah, and then it's 550.8 x, and then it was plus this big number here, 68900. Now, if you plot that in Desmos, it just looks crazy like this. So what you've got to do is you got to change the scale on this. So I think I was doing this earlier when I was plotting this to check what was going on. You need to literally put like 0 there and like a 20,000. The numbers are just bananas in this question. So then you get like a reasonable looking function. Now let's see what we found there. So in that previous question, this function here, this is the volume function. So we can see that this is where the volume is. Remember, there's volume on the y-axis. This is the region where it's decreasing, and it's decreasing between a value of 36 and 204. And so that's what we've seen from before. I think we also worked out what it was doing after 60 seconds. And you can see it there, 74948. That was the answer I gave. It was up there a second ago, and as you can rewind. So yeah, so hopefully that's interesting, people seeing that. So back here we go, and we brand new question, brand new function. So we're told to find the local minimum. So what that means is you take a derivative, right, and you set it equal to 0. Now, taking a derivative of this, it looks like you need the quotient rule, but you don't. You can just add, because there's just a number on top, you can just bring the bottom up and call it to the power of minus 1. So then you got 16 pi h minus pi h squared. But you could use the quotient rule on this. It's just a bit overkill, you know. So then c dash h here, and what we do is the 20 does nothing, so it just chills there. And then you multiply down by the power, so then minus 20. Keep the inside exactly the same. This is the chain rule. Keep the inside exactly the same. Reduce the power by 1, and then multiply by the derivative of what's inside. The derivative of what's inside is a 16 pi minus 2 pi h, and then set this equal to 0, okay? Because we want to find the turning point. Now you can rewrite this a little bit, because when you're a minus 2 to the power, you're a squared on the bottom. So what this thing really is like, it's like a minus 20 on top, multiplying this thing. 16 pi minus 2 pi h, and then over this thing squared on the bottom. 16 pi h minus pi h squared, and then that's equal to 0. Now we want to find the solutions for this, so we just multiply both sides by the thing on the bottom. The bottom isn't anything that'll give a solution, so that just goes because we multiply both sides by it. And so it's the thing on the top that'll give us the solution. And we can also divide both sides by minus 20. Okay, so then you're really just dealing with 16 pi minus 2 pi h equals 0. That's the only thing that gets left here after you divide everything else out. And so you can see that h there is obviously 8. Okay, you can bring it across and divide both sides by 2 pi, but h is 8. Now h has units. H is in centimeters, right? But we didn't want h. We wanted the local minimum value of this. So we wanted c of h. So we actually got to sub back in and get c of 8. Okay, that's our final answer. So hopefully people remember to sub back in if they were doing the exam today. 16 pi times 8, and then minus pi 8 squared. And you can write that probably in a neat way. What's that there? I think it's something like 20 over 64 pi. Let me type it in here. So we've got 16 by 8, take away 64. Yeah, so this, in the neatest way I'd write this, I'd write it as 20 over 64 pi, and then you can obviously divide 4 above and below there. But they wanted it to one decimal place, so that to one decimal place there, c of 8 to one decimal place is, where did I write it? I think 0.1, and then it's centimeters per second. And again, they gave away the units, but you should have kind of worked out the units anyways from reading the question carefully, you know. But yeah, the answer there was 0.1, and I'll just type that in again to confirm. 20 over 64 pi, it is 0.1. Okay, so this thing turns when the x value, the h, is 8, and then its y value works out like 0.1. Now, there was only one solution there, you know, what we only got one value for h. So it's not like, you know, when you're taking the derivative of a cubic and there's two turning points and you got to work out who's the max or the min. They just basically told us that it is a local minimum. So we don't need to go and do our second derivative test there and then show the second derivative was greater than 0 to show it's a minimum. Okay. And anyways, to take another derivative there, it's a really nasty quotient rule. Okay. So they didn't want that. So we're not going to do that. But if you do, it basically always works out. I done it there earlier. It always works out greater than 0. So let me explain what I'm on about, because this is good for people learning, you know. So c dash h a second ago we had it written out. It was like 20 minus 20, and then it was a 16 pi minus 2 pi h on top, and it was something squared on the bottom, right? It was something squared on the bottom. It was 16 pi h minus pi h squared. Okay. You do a quotient rule on that, right? Let me get rid of this here. You do a quotient rule on that to get c dash dash h, right? You'll get some answer. You don't even have to put the 8 in. You can put the 8 in if you want. It'll still be greater than 0, but the thing always works out greater than 0 if you do the calculation on it. It basically works out like something squared times a positive number plus basically another thing kind of squared positive number over something squared in the bottom. So it has no way of ever being negative. That's what I'm saying, okay? So yeah, hopefully that makes sense. But you didn't have to do any of that second derivative test here, okay? All you had to do was find that h was 8 and then sub it back in there, get the whatever, the 0.1. So I'm going to graph that in Desmos for you, okay? Just so you can see this really weird looking function. But then that's homework for anyone who's interested to do the take a second derivative of that. So we have a 16 pi h, 16 pi x plus or minus pi x to the power of 2. And close it off. It's a crazy looking function, okay? It's like this. It's got two discontinuous things, but it's actually not discontinuous in this part here. And that's why See our minimum point there, it's 8 0.1 when you round it to one decimal place. So we just found that point there, okay? And then I've actually spoiled the next part of the question here because the next question shows when is the function valid. It's valid, as you can see here, between 0 and 16. But you wouldn't have had Desmos in the exam to prove this part F down here. So I'll show you how you do this without Desmos. So you can pause the video, obviously read this if you didn't do it today in the exam hall. So we're asked to find when is this function defined for. And this function will have a serious problem if you have a 0 on the bottom. Functions can't have 0 on the bottom, okay? So that's when this function starts to blow up. And so basically we just find out when it blows up. So we set the bottom equal to 0. We can divide everything by pi. And so if I take out a h here, I get 16h. I've divided by the pi on both sides, by the way. You take out 16h. You can't actually take out 16. Sorry, that's my mistake. You can divide out the pi, and then you can take out a h. And so then that leaves 16 minus h equals 0. And so the solutions to this thing will blow up when h is 0 and when h is 16. This thing will give an error in your calculator if you try and put 0 in and you try and put 16 in. So this function is valid when it's greater than 0 and less than 16. And you see in a graph of that there for why that is. This thing is completely fine as long as you don't put in 0 where it blows up all the way up there to infinity, and then you put in a 16 where it blow up there going up to another plus infinity. So hopefully people understood that. Bit of a tough question, that all that's in there. And you see, it's just taken so much time to do all of that out, and that was only question 7, That's why this exam took a lot of time to do. So the video is on 1 hour and 7 minutes there. So like I absolutely could do all the solutions out here in an hour, but like I'm actually trying to teach you a bit of stuff too as I'm going along. So that's why the video goes a little bit over the hour, even though the solutions only take an hour. Anyways, so you can pause the video, have a read of this. So this Rian guy has some piano and he's tuning the piano. A very, very dense question to read through this. It took me a while to kind of make sense of what they're on about, but then they hold your hand and kind of walk you through how to use the function. So you can read that in your own time. So Rian tunes the note that is 11 notes above A, and they even tell you this just means put 11 in for X. So we just do that. We go F of 11. We go 4, 4, 0 times 2 to the 11 over 12, right? And that in your calculator will work out as times 2 to the power 11 over 12. So you'll get yourself 830 to the nearest whole number. So it was you'll still write it out as 61, but then round it to 831, and this has units of hertz if you read the question carefully. Okay. Great stuff. That's that done. So then we'll do that was an easy mark, and then they also hold your hand here. This is a little tough here, significant figures. So if anyone doesn't know the difference between significant figures and decimal places, they might have lost a mark here. And if you don't know and you're in 5th year, go look it up. Rian tunes the note 6 notes below. Okay, so that means X is minus 6 if you read the question carefully. So then F of minus 6 is 440 times 2 to the minus 6 over 11. You type that in here. 440 multiplied by 2 to the minus 6 over 11. And I'm getting 301.4772. Now, if you left your answer like that, it'd be wrong because that's 4 decimal places. 4 significant figures is actually 301.5 hertz. Okay, so you only need 1 decimal place there to write that down. Did I type that in correct there? Because I'm looking at that. Or no, that's right there. Why did I write that as 311 when I done that in the calculator? Oh, where did I get the 12 from? I'm going crazy. This is the 11 from. This is a 12. So look, you have the solutions there. So that when you put a 12 in there, you don't get this number. Okay, you get 311.1270, and then when you round that to 4 significant figures, you get 311.1 hertz. Okay, so that is the answer to B. Okay, cool. Right, so we'll move on, and then the answer to part one, as we remember there, was the 831 as I called out, yeah. So I put the 12 in properly there. Okay, so we scroll down here, so I'm going to try and keep this function so we have it. Okay, Rian knows that the note that is 7 notes above, so that means x is equal to a plus 7, has a frequency of approximately this. Find the actual value. Okay, so what we do is find the actual value for when this is this. So this is what we really do. We put 660 in for f and then find x, if you read that carefully. So then this is 2. So you're going to need logs here because the thing you're looking for is in the power. So what you'll do first of all is divide both sides by 440. Okay, so you put the 440 there. Now that probably cancels down to 3 over 2, if I'm looking at that correctly. So really what you're dealing with is 3 over 2 equals 2x over 12. You use your logs now. The whole point of logs is to get the power on its own. So the power will be on its own. Then it'll be log. It'll have the same base as up here. That was base 2, so this will have base 2. And then that leaves one room here for the 3 to the 2, 3 over 2. And then we multiply across by 12 in our next line. Okay, so then x equals 12 log 2, 3 over 2. And then that works out as 7.01955. So you see it's pretty close to 7. And so to, what is it, to 2 decimal places, that's 7.02. Now what are the units on that? You could just say notes, okay? It's x notes, if that makes sense to people. So yeah, that'll be full marks there, 7.02. Okay, so you needed logs there. Find an expression for f dash x. So this was tough because we're not that used to taking derivatives of things that don't have e as the base, exponentials. So this was tough. So how do we do this for e? So I'll just write the answer so you can understand it. And obviously keep an eye on this here in the formula tables. Where is it? Calculus. So we need to do this here. When you're taking the derivative of a to the x, it stays the exact same as a to the x, and then it'll have an ln a. So our question will have an ln2 in it here. But that's only when you have an x there. Say if you had like a 5x up there in the power, you would then need to also multiply by the derivative of what's in the power. So then you need to multiply by 5. Okay, that's the chain rule, if that makes sense to people. So we're going to be using this rule here. Okay, we're using that rule there. Okay, so I'm going to hammer this out here because I don't want to waste people's time. So f dash x, the 440 does nothing. Okay, it just chills there at the beginning and at the end. Now, when you take the derivative of this, it stays exactly the same. That's how you take the derivatives of exponential. But in this one, you need to multiply by ln2, according to the rule. Do we stop there? No, we don't. We need to multiply by, according to the chain rule, the derivative of what's in the power. So we need to multiply by the derivative of x over 12, which is 1 over 2. Okay? And so it says don't waste time tidying that up. Okay, that would be the answer there. And it has units. It has units of hertz per note. Okay, hertz per note. They might deduct marks for not writing units, and this is pretty tough for the student to realize about the ln2, and then also to realize the chain rule requires you to multiply by 1 over 12. Okay. Great. And again, there's loads of differentiation tutorials like that on the YouTube channel if you're in fifth year and interested. Now, this was an extremely tough question. Again, this exam is just taking a lot of time. You know, it's a tough year. Just how meaty all these questions are. You know, so this is an extremely tough question. It's kind of well thought of, but it's tough. I'd say 90% of people maybe didn't get this out, and then some people might have guessed it and actually got it right. So the idea is here you do a bit of a linear approximation, right? If that makes sense to people. What we have is this guy's value, and we know that this is what the rate of change is. So let me just write the solutions just so people can understand what we're doing. So when you move 2 units extra over, it's just 197, your original thing, with your rate of change times 2. And now people have no idea where that came from. Okay, so I need to kind of teach you a little bit on this. So I'm just going to get the answer out of the way here. 5.8 times 2. Okay, because a lot of people will be kind of looking at the solutions video and they'll be interested in how this was done. So that's the answer, first of all, and it's in hertz, okay? Because it's another thing for the frequency of notes. So they don't say the units are hertz here again, but you kind of would have been expected to put a H said there if you even got the thing out. Okay, right. Let me explain this with some other type question. Let's say um, you're doing distance, right? Displacement. Okay, the displacement you are from your house after, let's say, 3 hours, or no, we'll do 4 hours. Okay, let's say you've been walking from your house for 4 hours, right? S of 4, right? S stands for displacement. Okay, S of 4. You've been walking from your house for 4 hours and you're 30 kilometers from your house now. Okay. Now, if we take the derivative of this, right? Um, S dash t, okay? Basically, ds dt we all know is the velocity, right? So S dash t, let's say your walking speed is 5 kilometers per hour. Does this make sense to people? So after 4 hours of walking from your house, you're 30 kilometers from your house. Okay. And your rate of change of displacement is 5 kilometers per hour. Now, what they've basically told you in this question is, what are you doing 2 hours later? So what we're really asked for, what's S of 4 plus 2 hours? What are we like 6 hours later from our house? How far away from our house are we? And you should pause the video and think about this. Well, if your speed at this moment of time, um, when you were 4 here, was you were 5 kilometers per hour, and you traveled for 2 hours, you'd go 2 times 5 and you'd get that you walked 10 kilometers. So what you do is you take the original distance and you add it to whatever the rate of change was, which was 5, and you do it for 2 hours because you go the 4 plus thing there, you know. And everyone should realize you're 40 kilometers from your house now. If your speed was 5 kilometers per hour, um, after 4 kilometers walking. Okay, but this is a linear approximation. This is assuming you walk at this constant speed. But in this question here, that's an assumption. Okay, so we can only estimate it by this what's called a linear approximation, assuming that the person's speed is constant at like 5, and assuming that the increase of frequency here was 5.8 constant. Okay, so that's where this 5.8 times 2 comes out of. Very, very tough question. A lot of people wouldn't have understood it. Some people might have guessed this, and hopefully this example over here helps people make sense of it. You're 30 kilometers from your house after 4 hours. You're traveling at 5 kilometers per hour. You go an extra 2 hours. You go 2 times your speed, and you add it onto the 30. You get 40 kilometers from your house. Okay. So we'll need to remember that number there. That number for people, it's disappeared there. Remember, it was 208.6 because it's tied into the next question. Okay, that was the estimate. Right, this was extremely tough down here, and I'm sure this took a lot of people's time to try and make sense of what's going on here. Very, very tough question, you know. So we'll do it out here because I'm sure a lot of people are here trying to see a solution for this. So I'll give you a really good solution to this. So you're told A and B are positive constants, right? The very quickest way someone could have done this using this helpful hint of draw a diagram is if B is greater than 0, this is exponential growth. So you could have drawn this here, right? Let me get a different color for it. You could have drawn that. And we would have known that this thing would have went through 0a on the y-axis. Okay, that's just what they do. When you let x be 0 here, e to the 0 is 1, and so y works out as a, 0a. Okay, you should know this from your exponentials. So then this is exponential growth because the power here, the base is greater than 1, and the power was positive. Okay, so it's exponential growth. So then you come out to this moment here, k. K could be whatever number here, right? Now what we done there a second ago, and then we've got our other point over here, k plus 2, okay? It's 2, it's a distance of 2 over, 2 notes over, okay? What we done a second ago is we done what's called a linear approximation. So we basically took our tangent. Our tangent had a slope of 5.8 there a second ago. Do you remember that? And so what we done was we took whatever our value was here. I do want to kind of keep the numbers for people. We knew that this number here was something like 197, and we knew that the slope, which is dy dx, the slope was 5.8. That's the slope there. And so we then basically moved 2 steps over, and we got this point here at the k plus 2, right? So you got that point there, and that point had a y value of 208.6. 8.6, right? Now, this would have been full marks if the student drew this diagram. That's what you've done with that linear approximation. That underestimates what the actual function does. See, it curls up, so it beats a straight line like that. So to get full marks here, your justification for this, justifying your answer, would have been this diagram, and you show that the pink dot is greater than the red dot. The red dot's your estimate using this linear thing, and then it doesn't actually track the way the curve grows, it outgrows it. So that would be a full marks explanation. So the estimate is too small. That red dot is too small, okay? That would have been full marks there. Now, great. We can actually work out so that's the first way, the easiest way to have solved this problem, okay? The hard way is to actually go and work out what that pink dot's y value is and show that it's higher up, okay? We're going to do that using some interest in algebra. So we were told there a second ago, if you can rewind the video and you'll remind yourself, g of x was 197. G dash x was equal to 5.8, right? So what we can do is we can work out g dash x here first of all. G dash x taking a derivative here. The a does nothing and the e to the bx stays exactly the same. And according to the chain rule, then you multiply down by the derivative of the power. So g dash x is basically equal to, and we can put in the 5.8. 5.8 equals ab e to the bx. That's one equation. And we get another equation by going 197 equals the original function there, which is a e to the bx. Now, this is a tricky simultaneous equation, okay? But the idea is here, look, if you have a e to the bx, you can replace it with 197. So you can rewrite this purple guy here as 5.8, bring the b out the front, and then it's really just a e to the bx. You can now put in 197 in there, and you can get b. 5.8 equals b times 197, and so b then is equal to 5.8 over 197. So there would have been a lot of marks in this question if the student didn't get the right answer, but they were able to work out this b value here. And it's nicer not give it as a decimal, but give it as this neat fraction of 29 over 985, if you could call that neat. So we have b, okay? And we've confirmed as well that b was greater than 0, as we knew it was, okay? So we know b. Now, you can think about this yourself. Is there any way to work out the original a value? And you can pause the video and try and do it yourself. There's not enough information to work out the other a value. We'd need another piece of information, okay? So we can't do that. So we have the b though, but this is a ton of this is very useful information, okay? So let me teach you then how we can work out how that can give us the value for g of k plus 2 when we know what the value of g of k was, okay? Remember, these aren't x's, g's are g of k's, okay? Right, so let's clear this away. So remember that b that I've worked out there. So we know our g of x is equal to a e. We've worked out b as 29. So this is such a tough exam because of just how tough some of these stuff are to kind of think up when you're in an exam, you know? Right, so that's the updated g of x. We know information about it, and it is indeed exponential growth. Now watch this. This is what I'm trying to teach you here, right? G of 0 is obviously a. You put 0 in for x, that's e to the 1, e to the 0, which is 1, okay? G of 1, right? When you move x 1 unit further, what that becomes is a times e to the 29 over 985, okay? You've put 1 in for x. What's g of 2? It's going to be the same thing, but you put 2 in for x there, right? But you can write that as this. It's really just whatever the last thing was, multiplied by another one of these e to the 29s over 985. Okay, this is tough, but think about it. They have the same base, so their powers add. So what you really get is a 29 over 985 times 2, which is the same as putting 2 in for x. And I'll do one more here. Pause the video, obviously, and give this a go yourselves. What do you think g of 3 is? It's basically just put 3 in there for x, but you could write it like this. And the reason I'm getting you to see this is that you can maybe see the pattern of how you compare g of 1 to g of 3, which is 2, a space of 2 further away. Okay? 985. So again, this video is definitely going to go over an hour, but the reason it's gone over an hour is because I'm teaching you all of this interesting stuff, okay? So think about this. G of 0 and G of 2 are 2 apart, okay, in terms of their x value. What's the difference between them? You've multiplied by this thing twice, okay? Study it again. G of 1 and G of 3 are 2 x values away from one another. All you done was multiply by this thing twice. So this is the big brainwave here. Whatever G of k's value is, right, you take, if you want G of k plus 2, which is 2 away from G of k, you just multiply it by these things twice. You take your G of k and you multiply it by 2 of them, okay? And that's what that pattern here tells us. So then you just multiply this thing by e to the 29 over 985, and then you multiply it by e 29 over 985. Now, we know things here. We know that G of k earlier on was 197, right? We can type this into our calculator. We can actually get the value of G of k plus 2, which if you rewind the video, I think was that red or pink dot, the taller dot, okay? So if you type 197 multiplied by e to the power of 29, you know what I'm typing in here anyways, yeah? 985, you'll get this number. You'll get 208.95 hertz, okay? Right? And what was our estimate? If you remember and you can rewind the video, our estimate was 208.6 hertz. And here you go. The estimate is lower than the actual value, okay? The estimate is too small. And we've proven it there by actually getting the value there as 208.95. So that for me is maybe, believe it or not, probably a little bit easier than drawing the diagram. The diagram was just so tough with the tangent and stuff for people. I'll just draw it here really quickly again. You had some exponential curve. You had some dot here. You had to draw a tangent to get some other point out here. And so you see that the point on the curve is higher up than what the tangent estimate can get us. And so that means the estimate is too small. But the much easier way, if you could say it was easy, is actually work out what the y value is of the taller point compared to the estimate and seeing that the estimate was too small. Okay, great. I hope people learned a lot from that question there if you're in fifth year or whatever. And anyone who sat the exam today can see how that was done. But you see, there's just absolutely no need to be asking this question again. This is why this exam took too long to do out. This was just tough enough. Why are you giving in another question here to just get this thing done, okay? So anyways, we'll do it out here. So you can pause the video and read it if you need to. S, A, T, and B are unknowns, and there's a choir. So they tell us the total number of people in the choir is 384. So we just write this. S plus A plus T plus B. You read this carefully. There are twice as many A's as there are sopranos. Now the way I write these is I always go A equals S first of all. And I read the question again carefully. Who is bigger than who? It says twice as many altos as sopranos. So altos is the bigger number. So I give the 2 over here to the S to pump it up. So hopefully that makes sense, people. You can rewind the video, play that slowly, and that should make sense what I'm doing there. There are 12 more tenors than basses, right? So again, I go tenors equal basses, and I read it again, who's bigger? There are 12 more tenors than basses. Tenors is bigger, so the B needs to be made bigger here, so it's really B plus 12. Okay, hopefully people are good with that. Let me get the page right here. Yeah. Okay, so next thing, there are 12 more. Yeah, the number of sopranos plus altos is 3 times the number of tenors plus basses. Okay, so I would write that as S plus A first of all equals tenors plus basses. Now, who's bigger? Sopranos plus altos is 3 times bigger than this. So you're bigger, so I'm going to give a 3 over here to pump this side up. And they're the three. They're your 4 equations. You need 4 equations because there's 4 unknowns. So this is a 4-piece simultaneous equation. Ridiculously tough question, given that you've had to spend all the time before solving all that tricky stuff about that guy with the note and the frequency. Okay. So yeah, so 3, we basically will write everything in terms of s. So I'm going to replace this a here with 2s. So 3, 8, 4 equals s plus 2s. Now, can we replace t plus b with something? We absolutely can, because this is 3 times t plus b. So if you divide both sides by 3, you get what t plus b is. It's s plus a over 3. Hopefully people can see that. So this is plus s plus a over 3. But we know what a is. A is 2s. Okay? So then what we can write here is 384 equals 3s. A is 2s, so then this is plus 3s over 3. You just show it for the examiner. So then that's like a 4s now, because the 3's cancel. So then 384 equals 4s. And you divide that out there, I think it's 96. S is 96. A then is 2s, so A is, what's that? Is it 192? It is. Right, we have S and A. So then we can get, so this is a tricky thing here now to get the B and the, what's this here? This is a 12. That looks like an R. That's crazy. Okay. So basically I can swap T for B plus 12. So this down here, I'm going to swap for B plus 12. So I'm going to write S plus A equals 3, swapping T for B plus 12. And then remember this looks, what is this? This is a B. That looks like a 13. Sorry for that, people. So then this is another B here. Okay. And so we know what S and A are. We know they're um, 192. Sorry, 96 and 192. So I'll just tidy this up a bit here and we'll multiply it out. So S plus A equals, there's two B's in there, so you get kind of like 6B plus 36. Okay. So then to get the B there, you go 96 plus 192, then take away your 36 and divide the answer by 6. And you'd obviously show the workings for the examiner there, but this is kind of junior cert stuff. So B then works out as 42, which it does. And then once you have B, then you put 42 in here, and then you get T is 54. And that's the question solved, and they probably have a neat place down the bottom for you to fill in your answers. They do. Okay, that was just crazy long question. And then you're met with this ridiculous question 9. It's just so hard to make sense of it, and you're probably running out of time and whatever. So I better go through this here because I don't want the video to go on forever. So you can read that in your own time and try and make sense of it, but it's pretty complicated. But what's actually easier is just deal with what's on the page here. So we can see that the middle number is going up by 20, and then everything out from it reduces 20 left and right. Okay, so this is obviously 100. Then this is 80. This is 80. This is 60. It's just so much easier to make sense of the problem by doing this than trying to read that rubbish above there. So this is a 20. And you can put commas between that if it got messy for you on the day. Okay, so the number of shuttles, so you can see there's 5, then there's obviously 7 there, and there's obviously 9 here, 4 before the 100, 4 after the 100. The total distance, so you can add these quickly. So there's 2 20s, there are 2 40s, and then there's a 60 in the middle, so I get a 180 there. Okay, and then what do we got here? This is pretty tough. So we have 2 20s, 2 40s, and 2 60s. So I'm going like 60 by 2 on my calculator. I'm going plus 80 by 2, and then I'm going plus 100. I'm sure you can all do this. This isn't the hard part of the question. I'm sure everyone got that out. Okay, there's 500 there. Filling the missing values. Okay, so what I'm going to do is I'm going to try take a snip of this because this is what's pretty important for us here continuing on this problem. Okay, right, suppose Ella keeps swimming indefinitely and longer and longer indefinitely. Find the length of the 12th shuttle in set 14. Now that's pretty tough. Okay, so what you've got to see here is a pattern. Okay, and there's various ways to do this question, but you've got to kind of spot a pattern, right? So we need to work out what's going on in set 14 here, right? And then the 12th shuttle will count in 12 numbers, okay, people? So, right, how do we do this? When you're set 1, it will kind of track what the middle value is, and we'll work back. from that, we need to see what the middle value is, okay? If I remember how I done this. So to track the middle value, this here is when n equals 1. This is when n equals 2, because that's the set number, right? So when n is 1, this in the middle is 40. When n is 2, this is 60. When n is 3, this is 80. So you can kind of come up with a bit of a pattern there for the middle number. What you're doing is, to get the middle number, I'll call it mid, okay, is you're really taking you're taking a 40 and adding an n minus 1 times 20 to it, okay? If that makes sense to people. So when you put 1 in here, you get the 40 in the middle. When you put 2 in here, you get the 60 in the middle. You see how this generates the middle number, that middle pattern there. And you can obviously multiply this out, and you'll see it's really just 20 plus 20n when you times that out, okay? Right, so hopefully people are good with that. And you can test it works here for n is 4. When you put 4 in here, you get 20 by 4 plus 20, and that generated the middle number. Now, when we're doing set 14, again, this is such a tough question, and you're struggling for time and you're panicking and whatnot. So n is 14, right? So n is 14. We're going to try and get what the middle number is here. So you put 14 in up there. 20 plus 20 by 14. And you get that the middle number here was 300, right? So we also need to find out how far in is that middle number. So this is another really big thing, right? When n is 1, the middle number is 2n. When n is 2, the middle number is 3n. When n is 3, it's 4 shuttles in. So when n is 14, this is the 15th shuttle, if that makes sense to people. That's the 15th shuttle. So then the 14th shuttle is take 20 away. That's the 14th shuttle. 260 is the 13th shuttle. And the answer to this question, the 12th shuttle, is 240, and that has units of meters. It's a terrible question because you have to show, try and get some of those workings on the page, And yeah, the answer is 240. So, stupid question. Anyways, we'll move on. So this isn't stupid. This is like a junior cert problem, where they want you to create a formula for this total distance here, right? And it's a quadratic formula. So I said the junior certs could actually do this. So you would give them the sequence 80, 180, 320, 500, and you tell them it was quadratic. So what they would do is they'd get the first difference, 100. They get the first differences here, 140, 180, and then they'd go and get the second difference and show it's constant at 40, right? The rule here for A, if you've done this in the textbook and you remember it, A is always half the second difference in a quadratic pattern. So A is equal to half that second difference, it's 40. So you get A for free. A is 20, right? A is 20. Okay, I'll clear that difference thing away. So then you rewrite your pattern here. It's 20 n squared, and we're looking for B and C. So this is just a simultaneous equation. So you just put in T1. T1 will be the 80 up here. It's the first term. And then you go 20 times 1 squared plus B plus C, because n is 1. And that's 20 times 1 squared. So you get an equation that says 60 equals B plus C, okay? Right, then you just do the same thing with T2. T2 is 180. And you basically put n is 2 in here. So then it's 20 times 2 squared plus 2b plus c. That's 20 times 4, so that's 80. So you bring it over, so you get 100 equals 2b plus c. And then obviously you can take these equations away, it'll cancel out the c, and you'll be left with b is 40. And you can sub 40 back in there, you'll see c, or in there you'll see c is 20. And so then you just write it down. Tn is 20n squared, because that was A, plus the B you just found there, which was 40. And then C is 20, like that. You can move on from this happy in the exam knowing you've done it right by seeing does it generate T4, for example. So you go T4 to see if it gets the 500. You go 20 times 16 is 4 squared, plus 4 times 40. Oh, what's that? 160, and then add 20. 16s of these are 320. This is me doing it in my head. 160, that's 480 plus 20, it does give 500. So then you can move on knowing that this is 100% correct by seeing does it regenerate the 80, the 180, 320, 500, okay? I only tested one value there. It obviously works, you know. Right, so that was tough. That takes a load of time. And then we're down here now to D, and we have to do this. And sure, what is this? This is ridiculously tough here. In set H, some random thing, so we'll try and get this back up so we can have a go trying to make sense of what they're on about here. So in set H, shuttle 21 and shuttle 43 are the same length. Find the value of H, okay? So we can see there are things that are symmetrical. You see how the second one here, and there was 9 terms here, so the second and the 8th thing there, the second and the 8th had the same number. And when you're in set 3, say like the second and the 6th number have the same thing. Do you see? The third and the 5th number have the same number. So that's kind of what they were doing here. But this is so tough, you know, when you're panicking in an exam to try and see that pattern. So basically what we can do is we can just average those numbers and get what the middle shuttle is. So you show that for the examiner, just going like 21 plus 43 over 2. Okay, so 21 plus 43 divided by 2. So that means 32, right? So that means the middle shuttle is the 32nd shuttle, okay? So like whatever is going on in set H, right? The middle shuttle is the 32nd shuttle, okay? Right, so if the middle, we can work this out. In set 1, the middle shuttle was the second shuttle. In set 2, the middle shuttle was the third. In set 2, the middle shuttle was the third shuttle. So in set H, if the middle was 32, which is always one bigger than the set, we're in set 31. Extremely tough. You'll have to sit with that and kind of think about it for a bit, and you'll come to terms with the answer being 31, based on kind of what I walked you through there. Okay, so we come down here. This is another really tough thing here. Find an expression, and again, it's taken loads of time to solve all of this. Find an expression in K for the length of the kth shuttle in set 18. Like again, it's a load of mumbo jumbo when you're reading it the first time. You have to read it how many times to make sense of it. Find an expression in K for the length of the kth shuttle. Right, so these here are the shuttles, and we're kind of looking for what the number is, what the value is. So the length of this third shuttle was 60, if that makes sense. So find an expression in K for the length of the K shuttle in set 18. Right, so what can we understand? The main thing we got to get here, okay, in set 18, right, in set 18, the middle shuttle will be the 19th shuttle, right? Which means there'll be 18 shuttles before it and 18 shuttles after it. If that makes sense. So that's why this goes between 19 and 37, because the last shuttle would be the 37th shuttle, because 18 extra shuttles after 19, the last shuttle there will be 37. So we're kind of trying to generate a sequence to generate these last few shuttles, okay? So to even get us off the ground here, we need to work out what the 19 shuttles length is, okay? So we're going to need that formula we had there earlier on, which worked out the length of the middle shuttle. And if I can remember it, it was something like the middle shuttle was equal to, what was it? It was like 20n plus 20. So let's check if that was it. When n is 4, you sub it in there, you get 100, yeah. When n is 3, 20 times 3 is 60. So that works. This formula will get us the length of the middle shuttle. Okay, so we're in set 18, so n is 18 here to sub in up here. So 20 by 18 plus 20. 20 by 18 plus 20. So the middle shuttle in this complicated set thing here, let me try and not make this diagram so scary looking. The middle shuttle is 380. Okay, so that's the middle shuttle, and we're in set 18 here, right? So that means to the right of it, you have a 360, a 340, and that goes all the way down to 0, doesn't it? And we're interested, as I said, the middle shuttle here is the 19th, and the last one is the 37th, okay? Because there's 18 before it and 18 after it, okay? So we're really just trying to come up with a formula to describe this arithmetic sequence here that goes from 380 down to 0. Okay, so the first term is 380. The uh, the common difference, d, you get from taking the term after minus the term before. You can see it's minus 20. So then you create a Tn formula for this using your tables book. You know, it's a times a plus n minus 1 times d, and you sub in there, and you get, I don't want to hit the camera thing down there. So Tn here equals a, which is 380, plus n minus 1 times d, which is minus 20. And you go and you multiply all that out. And what will you get? That'll turn to a plus. So I'm getting 400 minus 20n. Now let's check if it works, right? When n is 1, or did I do that correct? N minus 1. Yeah. So when t is 1, yeah, when t is 1, you put 1 in there, that'll generate the 380. When you put 2 in there, you'll get the 360. And when you put, whatever this is, 19 in there, you'll get the last number anyways, the 0, okay? So 400 minus 20n is important there, okay? So hopefully people are good with that. Okay, so how then do we make this describe this pattern? Because we're not supposed to put in 1 here to get the 380. Okay, we're meant to put in 19 and get it. So this is a really tough thing if you do it this way. So you'd have gotten a ton of attempt marks for coming up with 400 minus 20n to describe the numbers going from 380 down to 0. Okay, so the idea is here, and you can pause the video and slowly kind of think through what I'm about to say to you. Okay, when we put a 1 in here, we get 380, but we actually want to get 380 when we put a 19 in there. So we want the function to feel like we've put a 1 in there when we've actually put a 19 in there. And the way you do that, if you pause and think about it, this will make sense. I better use red here because it's a more distinct color. The way you make the formula feel like you put a 1 into it. Where's the 400? 400 minus 20. So you do something to n. You're going to put a 19 into it, but you want it to feel like you've put a 1 into it. So you do n minus 19. Okay, so let's think about it. N minus 18 actually, probably. Okay, so think about it. We want it to feel like we put a 1 in here, but we're actually putting a 19 in there. So you put a n minus 18. So you put the 19 in now, goes 19 minus 1, which is 1, minus 20, take away 400, and it generates the 380. Okay, so then you tidy up this formula, and this will be the final answer. When you multiply that out, you see you get 20 by a plus 18. So that's a 360, if I am correct. So then that's a 760. 760, and then you have a minus 20n, and that is the full marks final answer for this question, okay? It's 760 minus 3n. Extremely, 760 minus 20n. Extremely tough. And you can check if it's right by subbing in the numbers. You put 19 in there, and obviously you want to write it in terms of k, so it's tk is 760 minus 20k. Put 19 in there, 760 minus 20 times 19. I get the 380. You go and you put a 20 in there. I get the 360. You go and you put a 37 in there. You get the 20, which is the final shuttle, okay? So that is the full marks final answer. Look, I don't know what to say to you. It's just such a tough question. You know, I don't know what they were doing. And guess what? It doesn't even end there. So again, they really messed up this year in terms of the time the students needed to solve the entire exam. This is a nice question, but this is just so time consuming. But you're asking us another question. You know, you're asking too many questions in one paper. And sure, you can see the video there. It's on 1 hour and 48 minutes. They shouldn't usually be this long, these videos. Okay. Anyways, as part of her training, Ella is lifting weights. She has 2 formulas here to see what her M is the, what is it, the max. The M is reps. What is M again? M is your maximum weight. Fair enough. And there are these 2 formulas. Anyways, it just asks the difference. You can just follow the instructions. Set R to be 5 and then get the difference. So you put 5 into the first formula. W times 1 plus 5 over 30. Let your calculator worry about that, or you can do it in your head. 1 is 30 over 30, so this here is 35 over 30w. You can simplify it if you want. This then is the other one. You can say MB and ME if you want to be neat, or you can just do a line through it like this. It's W times 36 over 37 minus 5. I'm sure everyone could do this question, you know, it's easy. Then this is W times, I'll write it neatly. This is 36 over 32W. You pick up your calculator and you take the two things away. You can call it a delta if you're okay with that, or you can just go M minus M. The idea is we're going 35 minus 35 over W, 35W over 30 minus 36W over 32. Type that into calculator again. 35 over 30, take away 36 over 32. Yeah, and you get 1 over 24 is the answer. And don't forget your W's. So the delta, that's what that means. You don't have to use that symbol if you don't want to. You can just write the word difference if you want. Is W over 24. Okay, that will be full marks there. And it has units. M is the maximum weight you can lift in kilograms, so this should have been in kgs, okay? The difference is W over 24 kgs. Solve the equation to find the number of reps when the two formulas give the same value for M. Super simple. You just set them equal to one another. See the W's cancel. Okay, and then you're just really left with 1 plus R over 30 is 36 over 37 minus R. We'll cross multiply here, but what we'll do is we'll write this as a single fraction by multiplying above and below by 30 here. Okay, so then what we've got is we've really got 30 plus R over 30 is equal to 36 over 37 minus R. We'll cross multiply and we'll get 30 plus R times 37 minus R, and then you go 30 by 36 and you get 1080. Square, multiply this bracket out, 30 by 37, so you get 1110. You get a 37R and take away 30R, so you get a plus 7R, and you get a minus R squared equals 1080. Bring it all to one side, that keeps the R squared positive, minus 7R, this comes over. I'm seeing, is that a minus 30? Equals 0. Factorize it, R minus 10, R plus 3 equals 0, and so the solutions are R equals 10, R equals minus 3, R can't be negative, and so it's 10 reps. The formulas give the same value when you do 10 reps. Okay, and you can just write reps as the units there if you want reps. Okay, and the question's done, but it took way too long. The whole thing took too long, okay? Question 10 out of all the long questions is actually the quickest question to do, but it's extremely difficult if you didn't know how to move functions up, down, left, and right. Now, there's a really, really good video on the YouTube channel called Graph Tricks, okay? And I highly recommend people watch that, and that'll explain a lot about this up, down, left, and right. So anyone who'd watched that video before this exam did it felt a lot more comfortable with it. So the idea is here, you're given a function called g of x, and then they give you a hint here. They maybe shouldn't have given you this hint. It's very, very giveaway. It's that if you want to move a function, if you add 1 to g of x, it moves the function up by 1. Okay, so it's 1 unit taller. And so they're like, plot on the diagram g of x plus 3. So you just basically move it up 3 units. So this here moves up 3 units, so it'll be like here. This is at a minus 1, so this will be at a 2. Then this is here, so this will be at a 3. We're just moving every point up 3 units. This is at minus 2, so this will be at a 1. There you go. That's g of x plus 3. Okay, because it's... Oh, where have I done that? Yeah. I've gone too high. I've gone 4 units, I think. I've gone 3 units up here, and then I've gone 4 units up here by accident. This was down here at minus 2, so then this should be here. Okay. This should be here. So I'm just trying to draw the original thing there. Down 3 units. Yeah, so if you're at minus 3 here, you need to be there. Okay, so every line now is that's 3 units taller, 3 units taller, 3 units taller, 3 units taller, 3 units taller. Okay? Okay, hopefully people are good with that. The diagram below Now this is the left and right thing, so this would have been in that YouTube video on the YouTube channel as well called Graph Tricks. So when you subtract 1 from your x, that actually moves the function right by 1, okay? And they actually gave this hint. They, again, maybe shouldn't have given this hint, but again, this exam has been so ridiculously tough, why not give the hint? It helps. So you can see it moved the original function to the right by 1 unit. So if you add 2 to the x, it actually moves your function to the left by 2 units. So that goes left by 2 units, this goes left by 2 units, and wherever that thing is there, ooh, it's tricky, it's like kind of there, maybe? Okay, so then this is the new, let me get another color. So this is the new function here. Okay, so you see it's 2 units over all the way, you know? 2 units to the left. If you add 2 to the x, you move 2 units left, okay? So it's nice to see this asked because this was due to kind of just examine this kind of thing with students, you know? And I made that YouTube video for it, particularly called the graph tricks. Okay, so yeah, so that is you add 2 to his x and it moves left. It's a counterintuitive, the left and right. Okay, all right, let's move along. So this was a weird question here. You're asked to state the period. So how long does it take to repeat? So let's imagine you start here, you go up, over, and down, and you're about to do the exact same thing again there, okay? So it's a question of how far are these dots apart here? They're a distance of 5 away. And so the function repeats itself every 5. So the period is equal to 5, okay? You just write period. And it has no units. There's no units in this question. So then there are an infinite number of whole numbers for which the graph f of x is just equal to itself, are the same. They're just on top of one another if you read that slowly. This again is just moving the function left and right, okay? So state 3 possible values of n, okay? And it says n can't be 0, of course, and n can be any integer it wants. So basically, they just want you to see that n here, n could be 5, n could be 5, n could be 10, n could be 15. It's any multiple of 5 because if you move the function, I'll do it here. When you add 5 to the x like that or take 5 away, it just moves it 5 to the right or it moves it 5 to the left. So the function becomes exactly as it was before when you just add 5 to it or take 5 away from it, okay? So that's why you can just move it 5 to the right, move it another 5 to the right, and another 5 to the right. It just looks exactly the same. And you could also go for a negative value here as well if you wanted, okay? Anything that's a multiple of 5 is an answer there. Again, pretty tricky, that. But you can actually get that question done pretty quick. So this here, when they say get the integral of a function with respect to x, they're asking for the area between the function and the x-axis. So we're basically looking for this area here. That'll be a negative area because it's below the x-axis. We're looking for this little triangle here's area. We're going to look for this squares area. So we're getting the area between the curve and the x-axis from 0 to 3. And so we want those 4 areas and we'll add them together. Now, the only tricky point to get here, I wish I kind of zoomed in on this. We need to get that point there. You see it's somewhere between 0 and 1. So the way we get that is by creating the equation of this slanted line here. Now, we can work out that line slope. It runs 1, and it rises 3. So that slanted line there has a slope of 3. It has a y-intercept of -2. So that line I'm pointing at there has an equation of 3x minus 2 mx plus c, you know. And so we can find where that line crosses the x-axis here by setting y to 0. When you set y to 0, you find where your x-intercept is. And so you set y as 0 there, you get 3x equals 2. And so x is 2 over 3. And it looks about that if you want to zoom in on that on the YouTube video. So that's 2 over 3 there. So let me draw the shapes now. So this first shape has a base of 2 over 3, and it has a height of 2 units. You go half base times height to get this negative area because it's below the x-axis. You go half base times height here, you'll get a negative 2/3 because it's below the x-axis. We'll get the green triangle now. Because this is 2/3 across and this is 1 here, this is only 1/3 across this way. It is a height of 1, and this is a positive area because it's above the x-axis and between the curve. And so you go half base by height there, you'll get that area is a 1/6. Area of the square is obvious. It's just 1 by 1, so that's 1. And then we'll do the pink triangle now when the question's done. I can probably fit it here. It has a base of 1 and a height of 1, and so it's half the base times the height and has an area of a half. You add them all together. The answer to this question here, integral from 0 to 3 f of x dx, is those 4 areas added. The area below is a negative, and then you add it to the sixth, you add it to the 1 for the box, and then you add it to the half. And you see that's minus 4/6 plus a sixth. Anyways, it works out as 1 from what I remember. Let me type it in again. Plus 1 plus a half. Yeah, and the answer to that there for full marks would have been 1, and your workings would have been those shapes that I done there, okay? Because you can't integrate that function because it's kind of made up of lots of different functions, you know? Yeah, now you could have absolutely kind of made that function I had there, the y equals 3x minus 2, and integrated that from 0 to 1 and got an answer, and then just added it to 1 and added to a half, and that would have saved having to do the triangles that I done there, okay? That would work too. So the answer there was 1. Okay, so we got this here now. So what I need to be able to do this is I need to keep a sketch of this for you up here, just so you can understand what's happening. A little bit of a tough question this, but I don't think it's actually that tough. I think this is a fair game question, but the overall exam is just taking way too long to do out, you know, so that's the bigger problem. We're asked to basically graph f dash x here. So the reason they put a horizontal line at 3 there is because f dash x is the slope of the tangent here, and so the slope of this line all the way up here, if you're to draw a tangent, as we showed you a second ago, was 3. So the slope of the tangent from 0 to 1 is 3. What's the slope of this here? The slope of that is 0, and that's why they drew a horizontal line here going from 1 to 2 for a value of 0. Now what's the slope from here to here? Well, we drop 3 units and then we run 3 units from 2 out to 5. So the slope of that line is minus 1. And so what you wanted to do here to get full marks was to draw a horizontal line down here, constant value of minus 1 between 2 and 5. And then from 6 onwards here, we're back with the slope of 3, because you run 1, rise 3. So then you're back up here. So that'd be the full marks there. Horizontal line there, you want to draw your horizontal line there at minus 1 going from 2 to 5, because that's the slope. And then the slope then goes back up to 3 from 5 to 6. Okay. You wouldn't have to show any workings from that. It's super obvious. Or at least it should be. Okay, then we're nearly there. The video's gone over 2 hours. Disaster. Okay, so how am I going to write now that I've done the video in an hour? Okay, let's say I just spent an hour teaching you. Let's say that, okay? Right. So what do we got? This is a bit of a tough question. Let me zoom in so that's not pixelated. There's no need for it to be so pixelated. Okay. So there's some other function j of x, right? And its integral from here to here is 200. So use this fact to get this. So you've got to know that when you're integrating things like this, you can split them up. So we can first of all say we're going to integrate j of x with respect to x, and then we can integrate b separately like this. Okay, and it'll give the same answer. 1 to a of b with respect to x. Now, if you read the question carefully, we can just replace this thing here with the number 200. So then we have a 200 there. So then we can actually integrate this because b is just a constant. So then this becomes, when you do the integral, 1 to a, then it's just bx. You don't say dx anymore. If that was a 7, it would be a 7x, you know. And so then we just put our integration limits in, okay? And so then that's just like 200 plus basically the square bracket with the upper limit in. So that's b times a. And then it's another square bracket with the lower limit in, which is 1. So then that's just b times 1. And then this here is really just 200 plus ab, take away b, and you can factor out the b if you want. So it's b times a minus 1. So your answer there for full marks would be 200 plus b a minus 1. Cool. And we'll finish off the exam now with this question down here. Like, this is a smart question. This is a smart question that they came up with here, but again, it's soured by how long the exam has took, you know. Derek is investigating if there are any functions that, now this is again the up, down, left and right. He is checking if there's any function, if we add 1 to the x, we move left. Is there any function that if we move it left, it's the same exact shape as if we moved the function up by 2, okay? So he's basically wondering, is there some quadratic, right, that if I move it to the left by 1 unit, it's somehow the same as a function that this original red thing moved up by 2. So it's probably not going to work out, as you'll see here in a second. It's not a quadratic that he's looking for. Anyways, they give us the instruction. We don't have to read the question too much. They say that h of x plus 1 is all of this. They saved us having to multiply this out because maybe they thought the exam was running on a bit long. They don't want the student to have to go x plus 1 and then sub it in there, a times x plus 1 squared plus b times x plus 1 plus c. But if you squared all that out and multiplied it out, you'd get that thing down there. Anyways, they just give us a very clear cut instruction. Set this thing equal to this thing plus 2. So let's do that. So that's ax squared plus 2. I'm sure people would have got this out if they got onto it and they had time. Bx plus b plus c equals h of x is just this thing. So you're just following instructions. You're subbing in following instructions, and then you add 2 to it. Okay, what cancels here? Loads of stuff cancels. This cancels with this. The bx's cancel. The c's cancel. Does that a cancel? That a doesn't seem to cancel. So what we're left with is 2ax plus a plus b equals a 2. Now this is called comparing coefficients. Are there any x's on the left? Or on the right, sorry, there are not. So that means the x's on the left don't exist. So 2a there is equal to the coefficient of x on the right, and that's 0. I've done a video on the YouTube channel called Comparing Coefficients, basically explaining why you don't need to use long division, that kind of thing. That's where this comes from. So a is 0. There's no x term on the right, so 2a must be 0. So if a is 0, then when we compare the coefficients, a plus b must be the 2. Constant equals constant on both sides. If a is 0, then that means b is 2. Okay? So that means if a is 0, this does not exist. And so the h of x that he's actually interested in is just a linear. It's a linear, and b there, what was b there a second ago? It was 2x plus c, wasn't it? Yeah. So, and I'll go into Desmos just to demonstrate this, but this is what they actually asked down here. State what information your values of a and b tell you about this graph of h of x. It's a linear, it's not a quadratic. And if I go into Desmos and show you this, let me get one that doesn't have the weird scale. So we draw the line y equals 2x, say, we'll pick a random number, 2x plus 5. Okay, we didn't work out c in this question, so it's 2x plus 5. Now, I am going to move that function. Remember, it was h of x plus 1, so I'm going to move it to the left by 1. When you add 1 to the x, you move it to the left by 1. So the way this would look is you isolate x and add 1 to it like this, plus 5. So do you see there, adding 1 to the x moves the function left by 1. Okay, and this whole, see that unit there is 1. Okay, so this whole question has found out for us that this is actually the exact same as if I took the original function and just moved it up by 2. So y equals 2x plus 5, and then if you want to move it up by 2, you just add 2. And there you go, look, it actually works. If the purple line is the blue line moved up by 2, see that it's moved up 2 units. Okay, see it normally crossed here, now crossed 7. Everywhere it's 2 units taller, but that's the exact same as having moved it over to the left by 1 unit. Do you see? And that was what the green curve was about. Okay. So hopefully people learn something from that. So look, it's a really cool question what they came up with there. That moving up by 2 is the same as moving to the left by 1 in terms of the graphs. That's why the green and the purple are on top of one another. But the exam is just too long to enjoy a question like that, So that's the end of the exam. I better end the video here before it goes on just too long. So hopefully you enjoyed that and you learned a lot from that. Obviously the video, I'm going to still put in the title that I done out the solutions in an hour, which I did. But the idea is that I spent about an hour teaching you all the cool, funny things that were in this exam, and there was loads, but the exam just took way too long to do out, So it's probably a bad exam and a bad year because of how long it took to solve all the problems. And some of them long questions were a bit crazy worded and long, Okay, look, if you enjoyed that, be sure to like and subscribe and leave a nice comment saying it helped if you're in fifth year or whatever, whatnot. If you're just done this exam today, you can say whatever you want, like it. This took time to put together. And there's loads of interesting YouTube videos for paper 2 on the YouTube channel, like probability, statistics, important past paper questions you should know. So go give them a look and they'll help you out for your Monday exam. Okay, thanks for watching. Best of luck. See you later.